We're next going to look at the average coefficients for different model sizes output. So this was at the bottom of the output. And what we're seeing is what the coefficients are given different model sizes. So these are based on ordinary least squares regression. What the 1x is telling us is what the coefficient for rational persuasion would be if it was the only variable entered into the model. If we wanted to replicate these results, we could just run a series of simple regression analysis. We'd only have one predictor in the model at a time. When we move to the 2XS, what has happened is there's been a series of models run for each one of the predictors. So rational persuasion has been ran in a model along with information exchange, and then the coefficient for rational persuasion noted. And then rational persuasion has been ran with a prize in a model. The coefficient for rational persuasion noted. Rational persuasion was entered into a model with consultation to predict trust. The coefficient for rational persuasion noted, and so on. And then we take the average coefficient for rational persuasion across every possible model that would include rational persuasion in another predictor variable. Again, what 3XS would represent is the average coefficient for rational persuasion given every possible model, including 3 predictors, one of which would be rational persuasion. We can go all the way to an 11 predictor model. Here, we're seeing unstandardized coefficients as well, and we can only run one possible model if we include all of our predictors within it. And so our coefficients here are going to be the same as what we would observe in our multiple regression analysis. The relative importance of predictors varies as the model becomes more and more complex. The coefficients for these variables change as more and more variables are entered into the model. The coefficients tend to become smaller, and this is because the variance in trust is being partitioned over a larger number of variables, and there's going to be some overlap within these variables. So the more variables there are, the greater the potential for overlap. And so in particular, what I'm looking at is what are the most important predictors in a particular model, and then how it is that that changes as we add more and more variables to a model. So as in 1x, I'm seeing that consultation is the greatest predictor, collaboration is the second greatest predictor, and then pressure is the third greatest predictor. And this was consistent with our LMG estimates, at least in terms of what the 3 most important predictors were. When I move to the 2XS, I'm seeing that pressure is the most impactful, and then collaboration, and then consultation. When I move to the 3XS variable, I'm seeing that pressure is once again the most important, consultation is the second most important, and collaboration is the third most important. Also notice how the coefficient for a prize goes from 0.18 in the model where it would be included with itself to 0.02 in the model with 2 predictors in it, to become negative when there's 3 predictors in it. And that's become more negative as we have models that have more and more variables within them. But as I'm looking at this, it does seem like there's a clear pattern, and that pressure is the strongest predictor, and then consultation, and then collaboration. So this once again gives me a little bit more confidence